Right, more homework help with Jen, and we're still in chapter 2, and we're going to do 2 problems right now. We're going to work on 51 and 53 together. And one of the things that I want to kind of review is this symbol to describe our elements, where we have X, A, and Z. And X is the symbol for the element. Z at the bottom is the atomic number, that's the number of protons. And A at the top is our mass number, okay? So, based on that, let's come over. I'm only going to do a few of each one. So we'll start out on number 51 with A. And A says 79 BR, okay? And they want to know how many protons and neutrons are in the nucleus and how many electrons would be present, in a neutral atom. Sorry, okay. So we would look at our periodic table and we would find bromine. Yikes, sorry about that. Bromine is right here, okay, and it's number 35. So that means that we could put a 35 down here, that atomic number, okay, and so that means that we have 35 protons. In a neutral atom, we would also have 35 electrons, and to find the number of neutrons that we have, we would just subtract 35 from 79. Okay, which gives us 44. Okay, so 44 neutrons. Okay. So this is another isotope of bromine, 81. So just because the number of neutrons changes with the mass number, the atomic number is always going to be the same. So now instead of 44 neutrons, we have 46, okay? And everything else remains the same. We still have 35 protons, 35 electrons, and now 46 neutrons. And that's kind of the definition of an isotope. Everything is the same except the mass number, the number of neutrons. Okay, the last one on here, 239 Pu. All right, so I should have pre-found these because now I have to go find plutonium. Okay, and if I'm looking at this, oh, how horribly embarrassing. There it is. Plutonium right down here on the bottom, and it's number 94. Okay, so we come over here, and this particular isotope of plutonium has a mass number of 239 and an atomic number of 94. Now they'll all have atomic numbers of 94 for plutonium. So that's 94 protons, 94 electrons, because again we're neutral, we don't have positive or minus charges due to changing electrons, and we need to find the number of neutrons. Okay, so subtract this out, we have 5 and it becomes 14. Okay, so we have 94 protons, 94 electrons, and 145 neutrons. Okay, so now if we come over here to number 53, I started to write down what we're going to do and then got sidetracked. Okay, so if Z is equal to 8 and our number of neutrons is 9, they want us to write this in terms of our symbol A, X, and Z. Okay, so Z would be 8. Okay, that's our number of protons. Now if we add 9 to it, we get 17. That would be our mass number. And if Z is 8, then all we need to do is come over to our periodic table and say, well, there's 8 right there, which means that our symbol is an O for oxygen. Okay, so the next one says B, and it says the isotope of chlorine in which A is 37. Okay, so it's chlorine, so we have Cl. We know that A is 37, and we need to find our atomic number Z, and that is just this number right here on top, so 17. Okay, all right, now let's take a look at maybe, we'll do D, just to mix things up a little bit. Okay, and D says number of protons is 26, and number of neutrons is 31. Okay, so this is actually the same one as A. It's giving us the same information. So we would, our Z value, in this case is 26, number of protons is our atomic number. Our mass number would be neutrons plus protons, so 57. And we need to go find atomic number 26 over here, and it's iron. Okay, so we would come over here and then write